All right, so we're going to start with notes 4.5, and we're going to be solving radical equations. And what that means is we're going to be solving equations that have radicals in them. So whether it's a square root or a cube root, fourth root, fifth root, it has a radical already in it. Okay? And there are some specific steps that you really should follow. Okay? And they're going to be similar to other steps we've done before. Okay? For example, the first step is that you should isolate, okay, the radical if possible. Isolate the radical if possible. All right. When we were doing absolute values with the bars, we had to isolate the absolute values. So that was always the first step, isolate. Okay. Now, once you have it isolated, okay, you're going to raise both sides of the equation all right, to an exponent equal to the index of the radical. Go away box, okay. All right, so what I mean by that is if there's a square root in the problem, you're going to raise everything to the second power. If there's a cube root, you're going to raise it to the third. Fourth root, fourth. All right, so you're raising it to an exponent that's equal to the index of the radical, okay? And what that's going to do is that's going to help you get rid of the radical. So we'll talk about how that works out. And then the third step is you're going to have to solve the remaining equation. Right? Remember, solve means get a variable by itself. Okay? And so like you're going to have x equals something or r equals something. It's like it'll be a number. All right. Now, there's a catch. After you solve, you actually do need to check your answers most of the time. All right, so we'll talk about that. All right, so step 4 is going to be to check. All right, we call them extraneous, so check for, sorry, that was getting sloppy. Check for extraneous, let me slap this down a little bit. Extraneous solutions. That just means check your solutions, okay? Because sometimes you get extra solutions that aren't actually solutions, like they don't actually work when you check them, right? So you're checking for extraneous solutions, but you only have to do it if you raised both sides to an even power. So that means if I had to square both sides or raise both sides to the 4th, 6th, 8th, whatever, then I have to check my solutions. If I raise it to an odd power, I don't ever have to check. Okay? All right, any questions on the process? Obviously, it'll make more sense when we apply it to something. Okay? All right, so for our practice problems, okay, we'll just jump right in. All right, we are solving. And we will start with something with a square root in it. Okay? And we're just going to go through the steps. All right, so the first step is to isolate the radical part. That means make sure it's the only piece on a side by itself. Okay, so y'all hit me up in the chat box real quick. How do you get that thing isolated? What are you going to have to move, and how are you going to do it? Remember, it's algebra. Okay, good, Jordan. Yes, Remy. Yes, Tegan. Okay, add 8. Perfect. You guys are awesome. Okay, so if you do it to one side, remember you have to do it to the other side. All right, and that's going to isolate our radical. Okay? Well, that's not right. It should be 5. Sorry. Okay, so that's step 1. Now you're going to raise both sides to an exponent that's equal to the index of the radical. All right, so this is small enough for you guys to hold up with your fingers. All right, if this is a square root, what am I going to raise both sides to? What power? Good. Good. All right, we're going to raise both sides to the second power. Now, you don't have to write this down, but let me show you why we're doing this, okay? Again, you don't have to write this down. When you square something, you're really multiplying it by itself, okay? You're really multiplying it by itself. Well, remember we talked about a shortcut that you could take if you did a square root times itself? The square root just disappeared and you get the stuff underneath. Do you remember us talking about that? You can take that shortcut. Okay, that's exactly what we're doing here, all right? We can take a shortcut. A square and a square root literally cancel each other out. A cube and a cube root will cancel each other out. A fourth and a fourth root will cancel each other out, okay? So they cancel each other out. However, there is no radical on the right. So we actually have to square that number, okay? And so hopefully, well, not eraser, hopefully you guys get 25 on that side. All right? So now it's just a matter of using your algebra skills to get A by itself. Take a couple of seconds and do that real quick, please. All right. A lot of you finish this up. Alana, good. So A equals 6. You are correct. Now, I want to know if this is a problem that I need to check. Is this one of the ones where I need to check? All right, I see some head shakes, and you are correct. This is absolutely one that I need to check because I used an even exponent. All right, so I have to check. Now, what that means is that I'm going to go back to the very first line of my equation, and in place of A, I'm going to put a 6. All right, so I'm not solving anything, I'm simplifying. I'm just working out the left and then seeing if it ends up equaling the right. Okay, so you're welcome to type it in Desmos. If you type it in Desmos, all you have to do is type in the left. And if it tells you that it's equal to -3, then you know that both sides are equal to -3. Okay, or you can do it in pieces and do it in your calculator. Yes, so if the exponent is even, it has nothing to do with the answer. It's the exponent. Good question. Okay, so if I did it by hand though, let's see. This is 30. 30 minus 5 is 25. Square root of 25 is 5. I do in fact get -3, which is equal to -3. So -3 is not my answer. It just shows me that my answer of A equals 6 is correct. Okay, now, if you use an odd exponent, you don't have to check, but you can always check, and then you know if you're right or wrong. Okay, but if you use an even exponent, you have to check. Now, you don't have to check on your paper, like you don't have to write it down. if you know what to, like I'm just showing you that you need to check them. But if you can do it without writing it down, that's okay too. I mean, that's up to you, but this is notes and I want to put it on paper. Okay? All right, let's do another one. All right, we'll do another one with a square root just to make sure we're okay. And then we'll do some bigger roots. All right, so I'm going to give you a minute to try this one on your own, but don't forget to check your answer. The work is very similar to what we did in the last one. Don't forget to check your answer. All right, so for the recording, I checked my work. I did not get the same number on both sides. So x equals 4 is not a solution. If it's the only solution, it's no solution. But what I'm talking about now is, could I have taken a shortcut? And the answer is yes. When you isolate the radical, even radicals will never equal negative numbers. All right, so if you notice that early, you can actually say no solution right from the start. But if you don't want to worry about just one more thing to remember, you can work it out as long as you check it. Okay? And then the index, yeah, so because this is a square root, even though it's invisible, that's why we chose to raise it to the second power. Okay, so they have to match. If it was a cube root, we'd raise it to the third power. Okay, these are all great questions. All right, so even radicals will never equal negative numbers. So if you happen to see that early, you can just say no solution. All right, but it doesn't happen often. So if it's one of those things that you just forget to look for, which is fine, please don't forget to check your answers. Okay? All right, let's keep on moving. Number 3, let's change it to a cube root. All right, now I've got a cube root and I set it equal to a negative. Can I use the thing I just talked about though, about it being no solution automatically? Can I use that? Remy's saying no, and he's right, because it's not an even root equal to a negative. It's an odd root equal to a negative, so I have to keep going. All right, so that's what I was saying, like if you don't want to worry about just one more thing to remember, just check your answers and you won't have to worry about looking for that special thing. Okay? All right, so this is a cube root. All right, so use your fingers. What do I raise everything to? What power? Good. All right, lots of people participating. Jemiah, Elena, Mickey, Jordan, everybody. Okay, awesome. All right, so we're going to raise it to the third. And we're going to do it on both sides. And just like a square root and a square cancel each other out, the cube root and a cube cancel each other out. Okay? So we just get the stuff underneath the radical. Okay? But on the other side, we actually have to figure out what is negative 4 raised to the third. Okay, so hopefully some of you have a calculator nearby. Negative 4 times negative 4 times negative 4 is, anybody want to help me out? Good, negative 64. All right, and then good, Remy and Jordan, make sure you don't lose the negative, because 3 negatives actually make the answer negative. All right, good job, guys. All right, so then we finish by dividing by 2, and we get negative 32. All right, now, do I need to check this one? No, why not? Right, because I used a cube, I used an odd power, all right? I used an odd power, so I don't need to check. So remember, I'm looking at the exponent that I used. If it's odd, no need to check. Odd is no need to check. All right, let's do another one. All right, let's do a fifth root this time. All right, and I'm going to put a little something extra in here. On the right, I'm going to put another fifth root. And I'm going to put a number in front. That's really sloppy. Okay, so this time I have two radicals. All right, well, you want them to be on opposite sides. You want them to be on different sides, okay? Because if they were on the same side with addition or subtraction, it would make it extremely hard to raise it to a power, okay? So you want them to be on opposite sides. Now, when you look at this one, the one on the left is definitely isolated. There's nothing else with it. The one on the right is not quite isolated because of the 2, but if I divided by the 2, then the one on the left would not be isolated anymore. So sometimes you can't isolate them, you have to leave them as is. And so when I go to get rid of the radical, something else will happen to that number in front, okay? Now, if it's a fifth root, what exponent am I going to use to get rid of it? Good, good. Okay, so that means I'm going to raise both sides to the fifth. Make sure you put everything in parentheses. And on the left, all right, the radical and the fifth, they just cancel, okay? And so I have 3x plus 2. But it's a little bit something different on the right, okay? Because there's a piece that is not under the radical. I actually have to raise that piece to the fifth. So this piece is not under the radical, so I have to raise it to the fifth. And then when I put these two things together, they cancel. Okay? So you have to make sure that you pay attention. If there's extra stuff in front of the radical, you have to actually raise it to that exponent. Okay? And 2 raised to the fifth is 32. You can use your calculator for that. All right? But the fifth root, or the 5 does get rid of the radical on the x. They still cancel out. Okay? And so now I'm just going to use my algebra skills to get x by itself. All right, so take a second and do that. It is a fraction. All right, so don't be afraid of fractions. Anybody want to type it in the chat box? A number over another number? You type it in as a fraction. Just use the division key on your keyboard. Good, Remy. All right, I got 2 over 29, as some of other people did, or you let me know that you did. Hopefully more of you did. Now I want to know if I need to check this one. Do I need to check? All right, I see a few heads nodding. Very good. Yay. Okay, you are correct. I do not need to check because I used an odd exponent. No need to check. Okay. All righty. Moving right along. All right, so this one has 2 radicals in it, but they're on the same side. And trust me, you do not want to leave them on the same side, okay? Because let me kind of explain why. anytime, and I'm going to just make this, like, I'm going to pretend the radicals aren't there, and I'm just going to say 3a minus 4. I'm just making this up. If I were to raise this to a power, okay, then technically I would have to write it out 4 times, and that would require a ridiculous amount of foiling. And I definitely don't want to do that with radicals, okay? And so that's why you absolutely want to isolate them on opposite sides if at all possible, okay? So hopefully you can tell that if we add the one that's negative to the other side, that means we have 1 on the left, and 0 plus anything, well, that just keeps the radical. All right, so we have the other one on the other side. All right, so now it's a lot like the problem we just did, where we've got radicals on both sides, and we have to use an exponent to get rid of the radical. What exponent are we going to use? I'm getting a couple different answers. All right, it is a 4th root. All right, so we're going to use a 4th. So we're going to raise it to the 4th on both sides. And remember, that gets rid of the radical on both sides. But if you've got a number that's not under the radical, you do have to put that with the 4th power. You have to do 3 raised to the 4th power. Okay? For the other pieces, though, the radical just disappears. For the other pieces, the radical just disappears. But for the 3, you are absolutely going to have to raise it to the 4th. And now it's a basic algebra problem. Get your a's together on one side, and then get a by itself. Yes, Janelle. Very good. All right, and then make sure that if it's a fraction, you reduce that fraction. And then I want to know if I have to check this thing. Anybody else have an answer they want to give? All right, anybody not get 1 over 40? You need me to explain? Tegan, is that a yes, explain, Jordan? Okay, so let's run through it real quick. All right, so we have to minus a, because we need to get the a's together. Are you okay with the 81? Did you get that part? Okay, so then 81a minus 1a is 80a equals 2. And so then, because it's the a that I want to get by itself, I had to divide that by 80. So 2 divided by 80 is what I reduced. Okay? Now, do I need to check this one? Yes, I do, because I used an even exponent. Now, I will tell you that it is not, this is just not one that you would be able to do without a calculator in order, to try to check this crazy thing. So what I would do is I would pull up Desmos, whether it's on my phone or on the computer. So I'm going to do it now to show you what it would look like. All right, so I'm going to open Desmos, okay, and I got to find my paper. All right, so I would literally type in, okay, let me pull up the keyboard, 3, all right, but then I have to figure out where do I get a 4th root of anything from, okay, so you guys need to know this. You have to hit the functions button, and then the miscellaneous tab, and then there's one almost right in the middle that says nth root. That's how you would read that. And then it will let you put a little 4 right there. And then if you arrow to the right, we would put 1 divided by 40 underneath. Then you have to arrow until you're not under the radical anymore. So you just arrow to the right, minus, make another 4th root. And then underneath that one, you're going to do 1 divided by 40. You're going to arrow to the right once, so you're not on the bottom of the fraction, but you still want to be under the radical when you hit +2. And if you look at the answer, it says equals 0. Okay? So I would absolutely take advantage of the calculator on a problem like that. All right, so I'm going to go back to my work here. We know that this works, so this is an answer, is my final answer. Okay? All right, now I'm going to change it up a smidge. All right, and I'm going to make it look a little bit different. And I want to know, why is this still a radical, a solving radical problem? Why do I put it in here? What can I do with x to the 1/3? Yes, Remy. I can convert it from exponential to radical. I can convert it. Remember we did that for homework? Okay. Now, what you have to make sure of is that you only convert the piece with the radical. So in this one, the 2 is not raised to the 1/3. So it's going to stay in front of the radical. And remember, the bottom of the little fraction is the root, or the index, and the top stays with the x. All right, so now it looks a lot more like one of the problems we did. So take a minute, isolate the radical, and then solve it. Okay? Isolate the radical, and then use some sort of exponent to get rid of the radical. All right, check your work. Let me know if I need to go back and explain any steps. And then I want to know if I have to check this solution. I mean, you can, but do you have to? Good, Kaylee. Good, Nikki. All right, you guys are correct. You do not have to check it because the exponent you used, all right, I don't even know if y'all can see the yellow. The exponent you used was odd. Okay? All right, let's do another one like that. All right. All right, so I want you to convert it to a radical, isolate the radical, and then solve it. Okay? All right. Good, Jordan. Yes, so you get 28, and it does work, so you get to keep it. But you do have to check it because you used an even exponent to get rid of your radical. Does anybody want to see it worked out? Okay, Kelvin. All right. So what I did first was I converted my exponent to a square root, right? The bottom is the index. Okay? Then I isolated my radical by dividing, because it's connected by multiplication. So I divided by -9. Let me give myself some more room. Okay? And so then that gave me my radical by itself, and then now it's equal to a +4. All right? So if I was thinking because it was even root and it was equal to a negative, you can't make that decision until you isolate it. So now it's equal to a positive, and then I have to raise both sides to the exponent equal to the index. That gets rid of the radical, but I do have to square the other side. And then I finish by adding 12. 16 plus 12 is 28. Okay? And then, of course, when you go back to check it, in Desmos, you can either type in the original with the 1/2 power, or you can type in the line where you converted it to a square root. That's up to you. Okay? All right, now I'm going to bump it up a notch here. I'm going to bump it up a notch. All right. Oh, that's not an equals. All right, so take a second and write this down. All right, and I want to talk about why it's really been bumped up a notch. All right, well, first of all, it's because there's more letters. Right? There's some not under the radical, and there are some under the radical. Well, you start the same way. You isolate the radical. Isolate the radical. So we're going to -7r. So we get the square root equals 1r, or just r. And then we're still going to use an exponent to get rid of the radical. Okay? But because there's no radical on the other r, you actually have to square it. Okay? And now we have to remember how to solve an equation that has a variable squared and another variable not squared and a constant. Okay? And so what we're talking about is we are now going back to solving problems that look like this, where you have the letter squared, then the same letter but not squared, and then a constant. Okay? And so now we're circling back to something we've done in the past. The only way to do this, however, is to make it equal 0 first. And you want to make sure that the letter that's squared stays positive. Okay? So the only way to make this thing equal to 0 and have r squared positive is to subtract the 12 from both sides and add the r to both sides. Okay? So we get 0 equals, and then we need to put everything in the right order. So the letter squared first, the regular letter in the middle, and then the constant at the end. All right, and now we really have to think back, think hard. How on earth are we going to solve for r? We have to remember how to solve for r. All right, and the only way to do it is to factor. Well, what on earth does factor mean? Factor means break it down into a binomial times a binomial. So that means we have to split up our letter, and then we have to find a pair that multiplies to be negative 12, and then adds up to be a positive 1 in the middle. Wow, we're really taking it back, okay? So we need a pair that multiplies to be negative 12, but then adds to be positive 1. All right, and a couple of you are typing in the chat box, positive 4 and negative 3, and you are correct. So in my factors, I'm going to put a plus 4 and a minus 3. And then I'm going to set each factor equal to 0, and I'm going to get r by itself. And then I need to know, do I need to check these? Do I need to check these? See a few heads nodding. Okay, good. I do need to check because even though it was way back in the beginning, I did use an even exponent. So I have to check and make sure you go all the way back to the beginning to do your check. Okay, so I'll give you a second to check, and you need to tell me if you're going to keep both of them, one of them, or none of them. All right, so negative 4 does not work, but 3 does. 3 does. All right, I've got one more before we can take a little break here. All right, so, and it's going to be similar to this one. All right, number 9. We'll just do a square root. Okay. So my first question here is the radical isolated? Yep. Okay, so we're ready to raise it to an exponent. All right, it's a square root, so we're going to raise it to the what? Good. See lots of people holding up their fingers. We're going to raise it to the second. Okay, now on the left, remember the exponent and the radical cancel each other out. But on the right, because there's addition inside, you cannot just distribute the exponent, okay? You have to actually square it out. That means you have to write it twice and FOIL, okay? You have to actually write it out twice anytime there's addition or subtraction inside, and actually FOIL it out, okay? So this side's going to stay the same for now, and then first, outer, inner, last. And then I'm going to take a quick second, and I'm going to add like terms. Okay? Now, because there's a v squared and other v's, I have to make this thing equal to 0, like I did in the last problem, and factor it. Okay? So I'm going to have to minus 2v, because again, I want my v squared to stay positive. And then I'm going to have to minus 3. Oh, let's change colors. And I get 0 equals v squared plus 2v plus 1. And then I'm going to have to factor. And remember, that's where you make the double parentheses. And this time we're going to find two numbers that multiply to be positive 1 and add to be positive 2. What's the only pair that multiplies to be 1 and adds to be 2? Good, 1 and 1. And they're both positive. Okay? So then you're going to want to set each one equal to 0, but if you already know it's the same thing twice, right? Because they match, yes? It's the same thing twice, so you only have to do the work once. All right, is this a problem I should check? You might have to go all the way back to the beginning. What exponent did I use? Good, Nikki. And that's even, so I have to check. Very good. And then you want to make sure that you check it in the beginning. So 2 times 1 plus 3, 1 plus 2. All right, this is going to be, wait, did I write something wrong? Oh, it's a negative 1. Thank you. All right, so then that's negative 2 plus 3 is 1. This side is 1. Okay, sorry, I had to plug in a negative 1. I messed that up. All right, so it works, and so we get to keep our answer. Okay?